So now let's look at some common shapes of data distributions and how they're related to the mean, median, and mode. We're going to first start with a skewed right distribution. So this first graph here, a histogram, is what's called skewed right. So let's move on to the last topic in this lesson called a weighted average. And this can also be called a weighted mean. And this is a special kind of average that takes into account how important each value is in the data set. So instead of treating every number equally, a weighted average gives more influence to values that have what we call a higher weight. It's more important. So we're going to start with the definition. In a regular average, in the mean that we talked about previously, we just add up all the numbers and we divide by how many there are. But in a weighted average, each number has a weight, and that's like a score to tell us how much that number should count towards the total. So the formula, it looks kind of complicated, but it's not as bad as it looks. The W stands for the weight, which is how important is the value. The XI's are the data values themselves. So this top line tells us to multiply each weight by each data value, and then the sigma tells us to add them all up. So this tells us to add the weights times the values. Then in the bottom, this says sum up all the weights and then divide by the sum of the weights. So in a real life example, a weighted average is used for GPAs. This is how your grade point average is calculated. And this is how I calculate your final score in the class as well, because exams are going to weigh more than the homework, or your final exam might weigh more than your regular exams. So that's where the percentages are in the categories for your total grade. So those percentages for the categories are your weights. So let's look at this example 4, with the student test scores. A student receives the following scores in different subjects. Use the credit weights to compute the weighted GPA, and we're going to round our answer to 2 decimal places. So in math, we have a GPA scale of 3.5 for that specific course, and the credit hours for that course was 4 credit hours. Then for music, they got a grade of 4.0, perfect score, with a number of credit hours for that course is 2. And then I'll let you read the rest. But basically, the credit hours are the weights, right? The more credit hours you have, the more heavily weighted it's going to be in your total GPA. So using this formula up here, we're going to take each of the weights and multiply it by each of the grades. The grades are your XI's, and these are your weights, your WI's. So we're going to take, for math, we're going to take 3.5 times 4, and we're going to get 14. For music, we're going to get a 4.0 times 2 credit hours. That's going to give me 8. For chemistry, we have a 3.0 times 3 credit hours. That's going to give me 9. And then for history, we're going to have 3.8 times 3 credit hours, which gives 11.4. So we multiplied all the weights and all the data values. So we just took all the WI's times all the XI's, And now that sigma is telling us to add them all up. So I'm going to add all of these values up. That's going to give me 42.4. So this is equivalent to the sum of the wi's times the xi's. Now, the bottom part of that formula, if we look back up here, says add up all the wakes, and then we're going to divide by the sum of all the wakes. So when I take the sum that means I'm taking 4 plus 2 plus 3 plus 3. That's going to give me 12. So that's this. Now the last step for our weighted average, we want to take the sum of all of our wakes times all of our x's, and we want to divide by the sum of all of our wakes. So I'm going to take 42.4 and divide by 12. When we divide, we're going to get 3.53 repeating. But when we round to 2 places, we're going to get 3.53. So this person's GPA is going to be 3.53. So let's wrap up the lesson with a quick summary. So in the beginning of the lesson, we talked about measures of center, and those are numbers that helped us describe the center or the typical value of the data set. We talked about 3 measures of center. We talked about mean, median, and mode. The mean is the arithmetic mean that we're familiar with, where we add up all the data values and divide by the number of data values. We talked about the median, which is the middle value when you order the data from smallest to largest. And it's also what we would call the 50th percentile. So we can label it as P with the little sub 50. We also talked about the mode, and that's the number that appears most often in the data set. Then we went on to talk about the shapes of the distributions and how the mean and the median and the mode are all related to the shape, and that they help make that shape of the distribution. And then the last thing we talked about was the weighted average. That's what we just talked about here in this example. And that takes into account the importance or the frequency of each value. So instead of treating each number equally, the weighted average multiplies each value by its weight and then divides by the total sum of the wakes. And this is especially useful when values represent things like credit hours or proportions. So whether we're describing a data set with a measure of center like the mean, median, or mode, or whether we're recognizing the shape of the distribution or calculating a weighted average, all of these are tools that help us better understand what the numbers are telling us. They're powerful tools to summarize and interpret real-world information.